Alright, as I said in that previous video that I'm going to work a few more examples of these compound inequalities for you. I've actually got 3 examples that we'll work through. This first one is an OR statement, so that means if the R number fits the description of either of these, that it would make it a true statement. So we're going to go ahead and solve the first one. This negative 2m plus 7 is less than or equal to negative 13. And then we'll solve 5m plus 12 is greater than 37. So let's go ahead on this first one. We need to subtract 7 from both sides. When we do so, that leaves us with negative 2m is less than or equal to 6. We need to divide by negative 2 on both sides, and that should set off an alarm for us. Remember, because if our inverse operation on an inequality involves multiplication or division by a negative, we need to switch the direction of the sign. So we're going to change the direction of the inequality symbol and go ahead and do the division, and we're going to end up with m is greater than or equal to negative 3. The graph of that one, we would have a solid dot on negative 3, and we would have it shaded to the right. So that's what that graph would end up looking like. On our next one, 5m plus 12 is greater than 37. They're adding 12, so we need to subtract 12 from both sides. The result of that would be 5m is greater than 25. Now it's just a one-step inequality, so we're going to divide both sides by 5. We're dividing by positive, so we don't need to worry about the direction of the sign. When we divide, we're left with m is greater than 5. Well, m is greater than 5 would be an open circle on 5, and it would be shaded to the right. Now remember, this is OR, okay? So if it fits either one of these, it makes it true. But if we go ahead and take a look at what this is going to look like when we graph it, when we graph the first one, m is greater than or equal to negative 3, this is what it looks like. When we put our graph of m is greater than 5, it looks like this. Now remember, this is the union of those two graphs, so the union of those two graphs would be starting at negative 3 and including negative 3 and go all the way to the right. Anything greater than negative 3 is going to make this, or greater than or equal to negative 3 would make this a true statement. Let's take a look at our next example. On our next one, we have an AND statement. Our first inequality will be 4 is less than w plus 3. Our second inequality in this compound inequality would be w plus 3 is less than or equal to 5. So we're going to go ahead and solve these individually. On this one, we need to subtract 3 from both sides. The result when we do that will be 1 is less than w. Remember, when we get ready to graph this, we want to read this backwards since the variable is on the right hand side. So when we read this, we're really going to read it as w is greater than 1. So when we get ready to graph this one, we're going to put an open circle on 1 because 1 is not part of my solution, but anything greater than that is, so I'm going to shade it to the right. On our next one, it's w plus 3 is less than or equal to 5. Again, we need to subtract 3 from both sides. When we do so, the result is w is less than or equal to 2. So on this one, we're going to have a solid dot on 2, and it's going to be shaded to the left because it's 2, and anything less than 2 makes it our solutions. So when I look at this inequality now, it's compound, it's an and so it's 1 is less than w, which is less than or equal to 2. So when I graph the first one, remember when we graph w is greater than 1, we've got an open circle on 1 and shaded to the right. When we graph w is less than or equal to 2, we're going to have a solid dot on 2, and it's going to be shaded to the left. Since this is an and, okay, the solution to this is the union of these two. Our number, the number we choose, anything that'll make this true has to make both statements true. So we're going to have, it's going to be starting at 1 but not including 1, and it's going to be every number up to and including 2. Anything in between there would be make our statement true. One last example, and then you guys can go ahead and get going. This one is another OR statement, so we're going to solve each one of these individually. So let's go ahead and solve 3 is less than 3w. They're multiplying by 3, so we need to divide both sides by 3. When we do so, we get the result of 1 is less than w, but we know we're going to read that as w is greater than 1. So when we get ready to graph this, there is going to be an open circle on 1, and we're going to shade it to the right. So we've got an open circle on 1, and we've shaded it to the right. Now let's solve the other half of this. We've got 3w is greater than or equal to 9. So when we look at this one, they're multiplying by 3, so we're going to divide by 3. When we do so, we end up with w is greater than or equal to 3. So this one will have a solid dot on 3, and it will have, and it will be shaded to the right again. So we're going to have a solid dot on 3 shaded to the right. When we get ready to graph this, we're going to realize that when we graph this, remember it's OR, so either one of these makes it true. It's a union of these two. So on this one, when we graph 1 is when we graph 1 is greater than, w is greater than 1, we've got an open circle on 1, and it's shaded to the right. And then when we graph our w is greater than or equal to 3, we're going to have a solid dot on 3 and shaded to the right. Remember, this is the union, not the, and so anything that makes, if our number makes either one of these conditions true, it's the solution. So our actual solution, our graph, the overlapping of these two graphs, is going to be start at 1, not including 1, but anything greater, all the way up. Guys, I hope this helps a little bit, and reach out if you have any questions.